Good afternoon. I am the project supervisor for the project mask detection and non-contact temperature checkup using IoT and artificial intelligence. The idea of our project is to detect the person with the mask, whether the person is wearing the mask or not. Also, the temperature checkup using the Internet of Things and artificial intelligence. Now, how is that we are going to bring in the IoT and artificial intelligence into this particular project is, we are going to use the Raspberry Pi module 3, Raspberry Pi 3 model, and also we are using the Pi camera, okay, which would be connected to the Raspberry Pi. Then we will also be connecting a non-contact infrared temperature sensor, which is going to be used to check the temperature of the person contacted to this particular kiosk what we are planning. So it is going to be designed by connecting this particular Raspberry Pi board with the Pi camera and the temperature sensor with the touch screen added to it, wherein it will display with the message the mask is detected or mask is not detected for the person. Also, it will be specifying the temperature onto the screen. Also, we are going to have a module through which the email will be sent to the administrator to whom we are going to provide this particular device. Also, there are some components you could see here which we would be adding is a servo motor, and then the pan tilt, which we would be using in order to rotate the camera whenever the person is identified or when the person is standing in front of that particular device. Also, the members would be adding once after I finish with my part, there are the team leader and team members would also be discussing about the flow chart as well the circuit diagram, and the next details would be discussed by the team member, also the team leader. Thank you.
Assalamu alaikum. I'm the leader of the team, and now I will continue with what my teacher said before, and I will start with project description. The main problem addressed in this project is, as we know, our world suffers from the spread of COVID-19, and because of the number of deaths recorded daily, which made people feel fearful or catching the virus, the government seeks to control the number of cases of infections by putting several laws that the citizen adheres to. The most important laws that the government put is wearing face mask and don't go out if you have or feel any of the symptoms of COVID-19, like high body temperature. But still, there is a class of people who don't adhere to the laws set. From this point, we get the idea of mask detection and non-contact temperature check-up using IoT. Specific objective: to secure a safe life for people, reducing the increase of viruses and diseases, to reduce mortality. Significance of the project: to record the percentage of people who don't wear a mask, to measure the temperature in a quick and simple way. Project scope: as countries around the globe are reopening, living with the novel coronavirus is becoming the new way of life. But to stop the spread of the coronavirus, we need to separate people having the coronavirus from the rest. According to CDC, fever is the leading symptom of the coronavirus, with up to 83% of symptomatic patients showing some signs of fever. As countries around the globe are reopening, living with the novel coronavirus is becoming the new way of life. But to stop the spread of the coronavirus, we need to separate people having the coronavirus from the rest. According to CDC, fever is the leading symptom of the coronavirus, with up to 83% of symptomatic patients showing some signs of fever. Many countries are making temperature checkups and masks mandatory for schools, colleges, offices, and other workplaces. Currently, temperature checkups are done manually using contactless thermometer. Manual checkups can be innovation, impractical in places with a large footfall, and risky. And to solve these problems, we are designing a kiosk that automates the process of temperature checkup by using facial landmarking and contacts, IR temperature sensor, and mask detection using deep learning neural network. And the use of this kiosk is not limited to schools, colleges, offices, and other workplaces, but it can be used also at high-risk area like hospitals. This device can also used at train station, bus stops, and airport, and so on. Our approach for this project is to build an efficient setup process such as anybody without any prior experience of computer vision or deep learning can use this. This will be a fully functioning and ready to use project. We are making this project highly customizable by adding code files for each and every stand-alone part and the full version. Using Amazon AWS credit, we are able to train our deep learning model for mask detection with good compute power using AWS EC2 instance. So now I will explain our project plan. First of all, we analyze the idea, then we meet each other to discuss the idea, then we discuss with the stakeholder, then the document a current system, then we design the project or the idea of the project, then we design the system, then we design the current diagram. After that, we create design specification, then we develop system models. In the last, we integrate with the hardware. A risk document plan has been prepared for our project. It has following things added. Purpose of the risk management plan. A risk is an event or condition that, if it occurs, could have a positive or negative effect on a project's objectives. Risk management is the process of identifying, assessing, and responding to and monitoring and reporting risks. This risk management plan defines how risk associated with the mask detection and non-contact temperature checkup using IoT and AI project will be identified, analyzed, and managed. It outlines how risk management activities will be performed, recorded, and monitored throughout the life cycle of the project and provides templates and practices for recording and prioritizing risks. There are a few more filed, but could not be explained here because of time limitation.
Flowchart. Flowchart started this first. Initiate the device. Initiate the Raspberry Pi to which of the camera integrated which will capture the image. Connect the camera. After capture the image, its mask detected. If yes, display message mask detected. If no, display message no mask detected. There are three modify. First, make mask detected. Second, temperature checking. Third, email to admin. After check the temperatures, they say it is temperature normal. If yes, send email to admin with image and details. If no, send email to admin with the image and details.
Specifications and how components connected to each other in our design circuit. I will start with SBC single board computer. It's a circuit board with a microprocessor, memory, input, output, and other features required of the functional computer. We connected SBC with servo motor and breadboard. BI camera, portable lightweight camera that supports Raspberry Pi. BI camera has many features like supports both Raspberry Pi Model A and Model B, MIBI camera serial interface, resolution 2592 1944, lightweight and portable 3 gram only, and etc. It connected to breadboard. Breadboard, a solderless device for temporary prototype with electronics and test circuit design. They are used for creating electrical connections between electronic components and single board computer. Servo motor. Normally, this type of motor consists of a control circuit that provides feedback on the current position of the motor shaft. This feedback allows the servo motor to rotate. The servo consists of suitable motor coupled with a sensor to review incoming signals about the position. It's connected with breadboard, SBC and BI camera. Jumper wires. An electrical wire or group of them in one cable with a connector or pin at each end, which is normally used to interconnect the components of breadboard or other prototype or test circuit internally. We connected jumper wires with other components. That's all about